Hello everyone, welcome back to the channel. So today we are going to discuss one of the most important services in the UDS protocol, that is diagnostic session control, also known as service 10. If you guys have already worked with CAN diagnostics, use ECU flashing, DTC reading or security access, uh, you might have already seen this service. Then, in fact, almost every diagnostic activity starts with session control. For example, if you think of an ECU like a secured office building, when you enter the building, you are initially allowed only in the public places. To access engineering rooms, server rooms, or any management offices, we need special permissions. So diagnostic session control works in that way. Mm. In this video, today we will learn what diagnostic session control is, why it is needed, the different session types, message structure, response format, mm, and negative response codes, NRCs, and some practical examples that is used in automotive projects. So by the end of this session, you will have a solid understanding of how the session switching works in real ECUs. So before that, if we guys have not watched my previous video, let us first understand what basically UDS is. So before we jump into service 10, it is important to understand what UDS is. UDS stands for Unified Diagnostic Services. It is an international standard used in automotive systems for communication between a diagnostic tester and an ECU. Whenever a service technician connects a scan tool to a vehicle, the tool communicates with the ECUs using diagnostic services that is defined by UDS. Through UDS, we can read fault codes, check sensor values, perform actuator test, program new software, configure parameters, and perform many advanced diagnostic tasks. All these activities are organized using service identifiers called SIDs. One of the first and most important SIDs is diagnostic session control, which has a value hexadecimal 10. Without selecting the correct diagnostic session, many diagnostic services, it won't work. Yeah. So let us understand what this exact uh, diagnostic session control hexadecimal 10 is. A diagnostic session control is a UDS service identified by service ID hexadecimal 10. Its job is very simple. It tells the ECU to switch from one diagnostic mode to another. Different diagnostic sessions provide different permissions. Normally, when an ECU powers up, it enters the default session. It means by default, uh, the ECUs will be in default session. In this session, only basic diagnostics are allowed. If a technician wants advanced features such as like memory access, software flashing, or extended diagnostic data, the tester must first request a different session. Because of this, diagnostic session control is often considered the gateway to ECU diagnostics. This diagnostic session control is also called the heart of UDS. Without entering the correct session, many other services will be rejected by the ECUs. Yeah. So as I said, so this is the first step in diagnostics. Uh, yeah. Why do we need the session control? Uh, yeah. Now you may ask, why doesn't the ECU simply allow everything? The answer is safety and security. Imagine if anyone with a diagnostic tool could update engine. software, erase fault codes, or modify calibration parameters. That would be extremely dangerous. Session control allows the ECU to provide different permission levels. Basic users can access only simple information. Authorized technicians can access advanced diagnostics. Manufacturers can access programming features. This layered approach prevents accidental damage and ensures that sensitive vehicle systems remain protected. It also helps manufacturers satisfy automotive cybersecurity requirements by restricting critical operations. So these are the common session types available in UDS: default session, programming session, extended session, and the OEM specific sessions after that zero hexadecimal 3. We can use it for OEM specific sessions. Most TCU supports at least three standard session types. The default session is the normal operating mode. The programming session is used during software updates and ECU flashing. The extended diagnostic session is used for advanced diagnostic operations. Manufacturers can also define additional sessions according to their needs. These are often called OEM specific sessions. Every session unlocks a different set of services. As automotive engineers, understanding these session types is important because service availability depends heavily on the active session. At a time, ECU can only be in one session to avoid overlap request. For example, the ECU can only be in default session at a time, or programming session, or extended session, or any OEM specific session. We can see here in the diagram, the ECU, if it is already in the default session, again we can request for the default session entry. And if ECU is in default session, we can request for the programming session or extended session entry. And if device or sorry ECU is in programming session or extended session, we can request for the default session. The similar way, if ECU is in programming session or extended session, we can request again for the programming session or the extended session. The first session, as we discussed, it is a default session. Whenever the ECU powers up, so it enters the default session automatically. As we said, this is the default, as the name only suggests, it is a default session. You can think of this as the normal state of the ECU. In this session, only safe and non-critical diagnostic services are usually available. For example, reading ECU identification information or checking some diagnostic data. However, operations such as software downloading, memory writing, and advanced testing are generally not allowed. Manufacturers intentionally keep this session restricted because the vehicle spends most of its lifetime operating in this mode. This helps protect the ECU against unauthorized access and unintended changes. So as explained, we can see why this session change is needed in real time. The first reason is reading extended data session. So this is not supported in default session. So the session needed is extended diagnostic session, hexadecimal 3. Why this is needed? Some data like freeze frames, extended sensor values, or vehicle specific data is not available in the default session. For example, reading additional fuel trim values or sensor status not shown in a standard scan. This freeze frame data and extended sensor values will be explained in the upcoming sessions. Yeah. Next reason is erasing DTCs, trouble codes. So this also needs extended diagnostic session or programming session. Why means clearing fault memory. It is a very sensitive operation, and so this is why it is not allowed in default mode. Yeah. For example, if there is already a fault occurred in vehicle and the tester has detected the fault and he has repaired it, so he wants to clear the fault. So to clear the fault, he needs to enter into the extended diagnostic session or programming session. And the third reason is writing to memory session. So for this, the needed session is programming session hexadecimal 2. Why it is needed? Program access is protected to prevent unintended overwriting or corruption. Uh, yeah. As name only suggests, here we will be doing some ECU programming. So that is why this memory access is protected to prevent unintended overwriting or the corruption. For example, updating when information or modifying any configuration data or writing any calibration values. So these are all very restricted memory access. So that is why anyone cannot access these things. So that is why we have to move from default session to programming session for updating this information in the ECU. Next is downloading new software like flashing ECU. For this also the needed session is programming session. uh, uh, Anyone cannot access the ECU for deleting already available software and downloading the new software. This is so the same way for this also the tester needs to switch from default session to programming session for upgrading the ECU software. For example, updating the engine control firmware to fix any bug or improve its performance. Yeah. As already discussed, the purpose of this default session, this is the initial session after the first boot up or the ECU startup or any reset is performed. It offers very limited access, as we already discussed. For further advanced diagnostic operations, we need to switch to different sessions like programming extended or any OEM specific sessions. Yeah. And here mostly read-only operations are supported. For write-only, either we have to switch to extended or programming session. Yeah, what we can do here in default session, we can read ECU identification, that is 20, hexadecimal 22. This is also called the read data by identifier. Reading any DIT, that is what this 22 does, and reading the DTCs through service ID hexadecimal 19. What we cannot do in default session. Writing the data as already discussed, erasing the already existing DTCs, programming the memory for flashing or writing any configuration into the ECUs, access security features. Yeah. So we will see the basic CAN frame format of this diagnostic session control. So yeah, the first byte it will be having diagnostic session control ID. uh, SID 10, hexadecimal 10, and that subfunction will be having diagnostic session type. It is from 00 to FF hexadecimal. And this is the response frame. So the first byte, it will be, if it is a positive, plus 40 will be added to the diagnostic session ID. So it is hexadecimal 50. The second byte is the subfunction, which we have given it in the request frame. So that will be added here. And the third byte to sixth byte, it will be session parameter record. Yeah, so this is the frame format or the syntax of negative response message. So the first byte, it will be having 7F. By seeing the 7F only, we should be knowing that our request has been rejected by the ECU. And the second byte, it is the requested session ID. And the third byte, it will be the negative response code, NRC. The NRC indicates why our request has been rejected by the TCU. Let us see what are the NRC supported for this diagnostic session control. Yeah. So the first one is hexadecimal 12. So this means the first subfunction is not supported. Whatever the subfunction we are giving it in the request message, so that is not supported by that particular ECU. That is why our request has been rejected. Next, subfunction 13. The message length or the format, whatever we have sent it to the ECU, so that is incorrect or invalid. So that is why our request has been rejected by the TCU. 22. Conditions not correct. This NRC shall be returned if the criteria for the request diagnostic session control are not met. Like for example, this when it comes means when we are trying to flash new software into the ECU, but the vehicle is not in a stable position. I mean, it is not parked. It is not in an ignition off. So the vehicle is moving. So what the condition, what it will do, it will check for the speed or the wheel rotation of the vehicle. So if it is greater than 0, then it means the vehicle is moving, it is not stable. So that time we cannot perform software flashing, as it can affect the vehicle function. So that time we will get conditions not correct, NRC. So this is an example of diagnostic session control service in UDS protocol. Below are the examples of diagnostic session control service in UDS protocol. The request will be from client to server and the response will be from server to client. Either it can be positive or the negative, but we should be receiving any response from the TCO. This is an example of default session can frame. We can see the number of bytes is byte length is 0 to and the diagnostic session control ID is 10 and the subfunction ID is 1. It means we are switching from default session to default session only. So this is the response we have got, positive response 06. So the plus 1 is added and this is the SID. Sorry, not the SID, subfunction, which is hexadecimal 1. Yeah. So the same, it is added here also. Positive response, 0x6 is the data length and 50 plus 40 is added, request SID. and is the subfunction. One is the subfunction for a default session. This is for the negative response. So here we are giving byte length as 4, and 10 is the mm, session ID, SID, and 1 is the subfunction for moving into the default session. We have got NRC length is 03 NRC, frame length is 03, and 7F is for NRC, and 10 is the subfunction ID, and 13 is the NRC. So 13 stands for incorrect message length or invalid format. Yeah, so this is correct because here we have sent 04 instead of 02. So that is why our request has been rejected by the requested ECU. Yeah, so we have got the negative response 13. Yeah, so this is the 4 is the data length, and 10 is the requested set, and 1 is the subfunction. Yeah, 3 is the length, and 7F is the negative response SID, and 10 is the requested SID, and 13 is the negative response code. This is all for the day. For remaining session types, extended and programming session, we will continue in our next tutorial. Thank you.